Now in month 3, then, let me just get back in the thing. Okay. Now in month 3, right, we have $201, okay? That's the balance. So the interest gets added, $2.01, that's 1% of this. Then we put our deposit in, and altogether we end up getting $303.01. And then this keeps on going on month 4, month 5, and so on. And this goes on how many years we're doing this, how many months we're doing this, excuse me. And this is the idea, calculation-wise, what's happening. We're making regular deposits, right? It's being compounded as well, right? It's not like in the chapter 5 where we leave the money in the account and do nothing, right? We're making deposits as well. Okay. But notice also the interest keeps on going up. I mean, you kind of would expect that because we're depositing money into the account. Not to mention also, we keep on compound. Every time we calculate our interest, that gets added to the account. So yeah, we would also expect the interest to keep going up as well. In other words, it's not like with simple interest where you just keep adding the same amount of interest each time. Okay, so now that we have done that, right? I know it seems kind of complicated to calculate the balance after a certain time period. It turns out there's a nice formula that can help us. This annuity formula. So here, this is our so-called annuity formula. Annuity meaning savings annuity. So A here, this capital A, this is the balance, how much is in the account T after T years, okay? That's how much is in here after T years. That PMT here, that's the regular deposit. How much you're putting in each year, each month. So in this example, PMT would have been $100. R is the APR. That's the annual interest rate. I know here we had to divide the annual interest rate by 12. When you're using the formula, though, you don't have to do that. You don't have to do that beforehand. You're plugging in the APR, but in decimal form. So in the previous example, it was 12%. So in the formula, it would have been 0.12. N here is how many compounding periods there are in a year. Here we divide it by 12, but in the formula, we do that as well here. Okay. T, again, is how many years or this is happening. It's time in years. Okay. And remember also, the compounding frequency, if it's not explicitly stated, we're always going to assume that the account is compounded with the same frequency as there are deposits. In other words, the number of times the account is compounded in a year is the same as the number of deposits made in a year, right? In the previous calculation, we did that, right? We were making a deposit each month. Each month, the account was compounded. I'm not sure what formula you would use, what the formula would look like, that is, if that wasn't the case. But we're not going to worry about that. I think people do consider that, but the formula gets pretty complicated. All right. So that's what this formula is. And just to help clarify, because we had chapter 5 as well, basically what I'm saying here is with compound interest, like in chapter 5, right? There's only one deposit. You're leaving the money in there and letting it build interest on its own. With an annuity here, you're making many deposits, though. You're not just leaving it in there once and letting the account do its thing. You're putting many deposits in there. That's what's happening here. All right. Okay. Well, let's do some examples to get our feet wet, so to say, with this concept. So let's suppose, again, this is an IRA. This is what I was saying before. It's a special type of account where you're putting money into it, like a savings annuity, regular deposits, that is. But again, you don't take money out of it, though, mostly because you're not paying tax on it. So you can't take money out of it, though, until you reach a certain age. I want to say it's 60 something, like 67, 68. I'm not too sure, though. But so let's suppose someone they marry deposits $100 each month, okay? Each month into an IRA. And it's earning 9% interest. So in other words, this is our APR. I probably should have said annual, but I think that's kind of implied. How much is she going to have, though, in 20 years? So again, she's making deposits each month, many deposits. Not to mention it's an IRA, which I just said is a savings annuity. Notice also it's not stated how often the account is compounded. You know, the frequency, that is. So because of that, we're just going to assume it's compounded monthly because she's making monthly deposits, right? We're assuming it's compounded as often as deposits are made. Okay, so we're going to use our formula. So we have PMT, that's $100. So that's 100. R is 0.09, right? Although, again, we have to convert it. It's the 9% written as a decimal. And we said it's 12. Since it's being compounded monthly, there are 12 months in a year. T is 20. Okay? T is 20, right? 20 years this is going on. We want to know the amount. We want to know the amount after, 20 years. In other words, we want to know what A is. So we put these numbers in, and then we do some wonderful, fun calculations. Of course, you're probably going to want to use a calculator here. Just remember, you want to follow order of operations. You want to make sure you follow that, okay? You work top and bottom separately, the numerator and denominator separately, right? With PEMDAS, that is, parentheses first, then, right? You do parentheses first. That's what I did here, right? Well, I mean, I did convert this to a decimal first, but that's okay. Then we get 1.0075. Exponent we do, right? That becomes 240. Right? We raise it to the exponent like I did, see? Then you multiply and divide and all that. Here we do parentheses first, then we do multiplication, and then we do division. Again, you just want to follow the order of operations. You want to do the inner parentheses first. You want to work in there first. Right? We have 1 plus 0.09 over 12. Okay, 0.09 over 12, let's calculate that first. That's 0.0075. Now we do 1 plus that, okay? We get 1.0075. The exponent here is 12 times 20, which is 240. So we raise it to the 240. Then we can subtract here, right? We get this. Then we multiply. And the bottom is just 0.09 over 12, so we divide. I mean, you could do this in Excel or Google Sheets if you want. That's up to you. You have to be a little bit careful. I mean, you have to make sure you use Excel correctly. But when you do all this, what you're going to get is this number. If you ever need help working in Excel, just let me know. Or Google Sheets, just let me know. That's a spreadsheet that's free. But this is what we get. So she'll get $66,788.69. That's what she'll get after 20 years. I mean, you could use the calculator in your smartphone if you want. You could. Might be, a little tedious, but it could be done. It's actually why on exams I tell people if they're going to solve it this way, show your work, okay? If you just wrote down the answer and did not show work and your answer is wrong, you're probably going to get no credit. So, all right. I mean, I'm not done with this example yet, but are there any questions on this? I mean, probably what I would do also is do again one step at a time using order of operations. When you round though, don't round to 2 decimal places until the very end. I would round to 4 or 5 or even more if necessary. You know, the more decimal places you use, the better, the more accurate your result will be. So this is what we get here. But let's also determine how much interest she earned in the account, right? The account is earning interest. You know, it's being compounded. How do we do that? Well, basically, it's what's in the account that did not come from her deposits, right? So she deposited $100 a month, right? And this is going on for 12 years, okay? No, excuse me, 20 years. Not 12 years, this should be 20. Although in the calculation I did 20. Let me just fix that here. Actually, no, let me do it this way. Sorry about that. Thought I caught all the mistakes, but I did not. That's all right. So anyway, this is going on for 20 years, right? We know there are 12 months in a year. Okay, so it's just like our factor label method, right? Let me do this actually. Right? We have $100 per month, right? That's what she's depositing. Now, okay, how many months are there in a year? There are 12 months in a year, so these months cancel, okay? And this is going on for 20 years, so these cancel, the units cancel. All we're left with is the dollar unit. It's just a factor label method. I mean, you could use proportions, but that probably would take longer. So altogether, we get $100, right, times 12 times 20, which is $24,000. Okay, so again, it's just a factor label method we're using. So from her deposits alone amounted to $24,000. Well, anything else came from interest, right? Anything else came from interest. Okay, so what was the interest then? This is the total amount minus how much she deposited in total. Whatever's left over is the interest. So the interest was this, $42,788.69. Again, the amount in the account that did not come from her depositing money directly, that's the interest. In other words, this is how much is in the account, but she only deposited in total $24,000. Well, anything left over had to have come from interest. That's what this is. So that's the total interest. Are there any questions about this? Okay. All right. Okay, so let me see. Let me stop the recording.